And our video is on. Hey guys, we're here for SmartDrone's Fast Aerial Lidar AMA. We're live with you from Tyler, Texas, and we'll be recording this webinar and AMA as well so that you can watch this after the fact. We've got, I think, 24, 25 people registered today. We're going to go through everybody when they registered wrote in some questions. So in a minute, we'll get to those questions and we'll start answering some of them with some slides and visuals. Really quick, if we could just introduce ourselves. My name is Thead. I work as the VP of Operations at SmartDrone. And so what that means is like business operations. When we go out to trade shows and events, you'll see me at those different places. Gentlemen?
I'm Taylor Dixon. I work as the data lead at SmartDrone. That means I do all of the data processing software and also any of the accuracy validation development.
And I'm Michael Ash. I'm what we call a field application specialist, but essentially I educate people about our product. I go and perform paid services for people that need LiDAR scans of their property, and I assist in customer service to help people who have our units out in the field.
Great. So if everybody will give me 1 second, I'm going to pull up our slide deck and we'll go ahead and get started. A quick overview and introduction for us. First thing, after this overview, we're going to have a case study. We're going to have Michael share some data and examples from the field of how people use this different type of data. We have, as I mentioned, taken your written questions from when you were registering. So we've put together a bunch of slides and we'll go through discussions on those. When you have different questions as we go along, please use the chat box. So if you look at the bottom of your screen, if you hover your mouse over the bottom center, you can click chat and you'll be able to use the chat box, write in with different questions as we go through. And we'll try to get to as many of those as we can as well. And then at the very end, we'll talk about how to reach out and how someone could learn a little bit more. So Michael, are you ready to share some data?
Yeah, let's do it.
Okay.
All right, looks like it's up there on the screen. So as you guys can see here, what we've been doing over at SmartDrone is combining our LiDAR data with photo data to be able to maximize your efficiency and get all the sensor information you could want on a survey. This particular scan right here was done of a local park here in Tyler, Texas. If we pull out some of these pieces of information here, we can see that we have a 2D image of the park. And what this is really good for is we can go through, we can use this to measure parking lot stripes. We'll let it render in right there. And, you know, for your like Alta type surveys, things like that, where you're trying to get your distance in some parking lots, but it's simply a 2D image. And so then what we can bring in is, say, our ground points. So our ground points allow us to see in 3D what we've been able to horizontally look at in the 2D. This, you know, really brings together your total, you know, surveying package for a drone and allows you to do a lot of things that, you know, you might not have been able to previously do with either developing orthos or developing LiDAR independently. This project was a lot of fun to develop all the different types of data we have, and relatively simple too, because every output you see here on the screen was able to be achieved through fairly simple processing, such as this full process result with all the different, you know, trees and buildings and everything in there comes out automatically with our processor in a few clicks. Our 1 foot grid down here with the creek running through it and all that also comes out automatically. And then our 10 foot is a user customizable box that we can enter that allows us to specify the grid size we'd like. Our contours we developed using this application called Cloud Compare, but you can also build Cloud Compares out of our points. It's simply an ASCII text file.
Contours out of the points by bringing something like Civil 3D.
Yes, exactly. Yeah, using Civil 3D, Trimble Business Center, Carlson, any of your favorite CAD softwares, you're able to easily import our data the same way you would have out of a collector tablet with a traditional RTK equipment. And then, of course, you can see we have an ortho that we use Pix4D to process and put together.
Thanks, Michael. So if you guys are all right with it, let's go ahead and pull up some of our slides again.
All right.
And let's see what we have to do here to get into the slideshow view. So Michael shared some of his data with us. Next thing, let's just jump into some of the questions. I think we've pulled out about 20 to 24 questions. We've got a slide for each one, and I'll read off the question, and then you guys feel free to answer them.
Awesome.
So first one, in the section of drones and hardware, can a LiDAR drone be equipped with high-res cameras for creating an orthomosaic while collecting LiDAR? So can those be done at the same time?
Yes, and that's what we're doing with our Discovery 2.0. Beforehand, we've focused on LiDAR and our vegetation filtering algorithms to give some of the data products that Michael was showing you earlier. But now we're integrating that camera to generate the orthos that Michael was also showing. So yes, within one flight, we get LiDAR and RGB photos.
Thanks.
That's awesome.
When it comes to drones and hardware, are there limitations with rain, cold, and wind?
Yeah, so there are definitely limitations with rain, cold, and wind, similar to the limitations you'd experience with your traditional RTK equipment. We're a piece of electronics, so if we have a light drizzle, something like that, there's no need to panic. Just let it finish the mission, bring it on back, and we don't recommend sending it back up if we have precipitation starting. And as far as wind goes, we can determine the rain, chance of rain and the wind with this little app over here called UAV Forecast. It's a free app that allows you to look and program each one of those boxes to show up as green, yellow, or red, depending on the parameters you set. So for instance, we typically set our gusts to where if it's over 20 mile an hour, it turns the box to red, which allows us to know right away, like, oh, that's a no-fly time. And then as far as cold goes, the particular concern there is cold soaking those batteries. And so we can do things like keep your truck running and keep the batteries inside the truck to keep them warm, and then pull them out of the warm truck, put them in the drone, fly your flight, and then put them back in the truck and get another set of batteries. So yeah, there's ways to work around these limitations.
And I think these are limitations like when it comes to cold that you'll face with drones in general. So like this image we found is a guy using his phone mount to keep his battery warm in the truck.
Absolutely.
So, guys, 1 second. This looks like I skipped a couple. So how much area can a drone cover in a single flight?
We get 50 acres with our Discovery 1.0. And that is if you're flying over a typical empty field or a parking lot. When you have heavier vegetation, you want to bring those survey lines in, so that way you can penetrate more vegetation. So if you have really thick vegetation, think more 25 acres, but with open fields, you can get about 50 acres of flight.
Yeah. And when Taylor says really thick vegetation, I mean, we're talking about as thick as it gets. Even in standard vegetation, I can usually get 35 to 40 acres, in like a pine farm or something like that.
Now here in East Texas, the vegetation does get thick.
Yes, it does.
So what would super thick mean? Just to build on that a little bit, is that bamboo and kudzu?
Yeah, kudzu would definitely classify as super thick vegetation. And it's also an example of, sometimes when you have a solid surface, maybe a drone's not your best option, specifically with the kudzu.
Yeah, we've also seen a lot of underbrush that hasn't been cleared from a forest. You bring those lines in, you can penetrate that as well.
Yes. Yeah, that really thick, like thicket, is that what you're talking about? Yep.
Thanks, guys. So when it comes to the drones and hardware, this question is, are malfunctions in landing, returning, and flight expected?
Yeah, so this is an excellent question. And you kind of have to frame it from the view of safety, right? I'm a certified pilot. And one thing we train a lot of over and over before you're certified, after you're certified, is like engine failures, electrical failure, things like this. And while they really, really rarely happen, we have to be prepared for them to happen. And the same is true when it comes to the drone world. So we need to prepare, we need to stay away from flying over people like the FAA recommends. We need to try to stay, off major roadways and free of people's property, private property that could be damaged by a falling drone. However unlikely, should be planned for.
Thanks, Michael. So this is a new section. Our first section was drones and hardware. this section is about the workflows. And I think there's 2 or 3 questions in here that really seem to center around the data processing. So how do I process LiDAR data in particular? So this question is, does a LiDAR drone need to be connected to a base station, or does the onboard GNSS receiver utilize network RTK solutions where available?
Yes, so the onboard GNSS receiver uses a PPK solution, which is similar to RTK, except it doesn't have to do it in the real time. We do it all in post-process with our simple one-click processor, which brings in your base station data and pairs it with the LiDAR data to get that accurate result we're expecting.
Okay, so this is a PPK solution we're using.
Yes, post-process
Okay.
kinematics.
Okay,
So essentially what you're saying is if you set up your local base and you fly the drone at the same time, you're able to take the data the local base collects and use it to process against the data the drone collects as well.
Yes, and actually, do you want to show them how we import that?
Absolutely.
So we work with most major base stations, Trimble, Leica, because all of them are exporting a Rhinex file or have converters to bring it into a Rhinex file. And so Michael's going to share his screen here, which shows our tool for processing. And if he expands the base station tab, you can see that we have a place where we browse and bring in that Rhinex file. You put in the control point that you were utilizing within your controls with your coordinate system, and then have your height of the receiver from your control point. And then from there, it's able to process and tie all of that data down to your control point.
nice.
Thank you, Taylor. I'm gonna hand back to you here.
Okay, so we'll go back to the slides. See if this one functions. There we go. So we were talking about the PPK solution there, and I've advanced. So this also talks about the workflow. Someone wrote in and said, how does a residential small lot survey work with LiDAR?
Yeah, so that's a great question. And I imagine the premise of this question was, is it still efficient to fly a drone over a job that wouldn't take my guys very long to collect, right? And so this is a sample little case. I cut out 2 acres out of a scan we had done. I, counted how many points were inside in there using the computer, of course. I'm not even sure I can count to 2.7 million if I'm being honest. And then I brought that down to how many were just ground points, and we had somewhere around 720,000. And then we brought that down to our 1-foot rasterized grid. We collect about 87,000 points over 2 acres. What that allows you to do is pull out really dense resolution over this topo for a small field. And you could even subsample that to like 2 or 5 feet as well if you needed to. And the key thing here is too, this 2 acres, if we were to set up and fly this, we'd be able to set up, fly, and process the data in about 25 minutes. And so the short answer is yes. I think it's very applicable for small surveys as well as large surveys.
Mm-hmm.
And I can think of one of our resellers, one of their first jobs, they were going out and doing a 1.5 acre survey, but it was in some of the gnarliest terrain that is out in Alabama. And it would just be so difficult to do that safely using traditional GPS methods, if it was possible.
That's a really great example.
And to add the final point, reshoots and going back out to the site is one of the most costly things when it comes to any job. And so when you collect the whole site and hand that type of data over to your client, you don't have to, if they come back and they're asking for more measurements, you already have that. You don't have to go out and reshoot. So that's another big advantage to utilizing it on small jobs.
Yeah, and that's one of the things that surveyors, civil engineers, and civil contractors have all been the most excited about when we're talking to them. It's like eliminating the rework.
Yep.
Yeah, every time you go out and fly, I've heard people call it a virtual survey. But really, you've collected virtually a 3D model of that whole space by the time you've flown over it. Okay, thanks, guys. So also in your workflows, how does a drone deal with steep terrains? And i.e., an example given was topoing on a mountainside. What are some of the considerations?
The considerations you have to do when you're planning on the side of a mountainside is that terrain level per collection. So as you kind of step up the mountain, you want to increase the altitude of your drone to make sure that you're clearing any trees or other tall structures that go up the slope. And additionally, you want to fly parallel to that mountainside. So that way, as it's doing its line, you can increment the altitude as it goes up. But with all things, proper planning is the key.
Okay. Michael, if you were going to plan a mission going up a mountainside, do you think it would take twice as long as a regular mission, or what would it look like to you? What would be some of your thoughts?
Yeah, I think 2 to 3 times around as long is a great estimate. And keep in mind, it takes about 1 minute to 2 minutes to plan a normal mission. And so when we say 2 to 3 times as long, we're still talking sub 10 minutes of planning time. And one thing I would do if I was planning this, just as a piece of advice, is I would plan down the mountainside. That way, if you had errors in your input of data or anything like that, you don't have to worry about it not increasing its altitude as you go up the mountain. You just have to worry about maybe having to refly because you were too high as opposed to too low.
That's a great point. All right, next one. Here we go. So also in workflow, is operating a heavier or larger drone more challenging for a new pilot compared to smaller drones that are used for imaging? So when they say smaller drones, they probably mean a $2,000 Mavic type of drone for collecting some orthos or photogrammetry. So is operating a larger drone more challenging?
Yeah, Michael, you've kind of just gone through that recently, taking the jump.
Yeah, absolutely. So the short answer is no. I mean, other than the fact that you might need to be able to lift closer to 15 pounds as opposed to a pound or two, it's really not hard at all. As you can see our Q ground control is what our flight planning looks like down there. And that's where you do all your stuff. If you're familiar with drone deploy or some of these other options, you'll see that a lot of it's very similar. You have different modes you select, you set the parameters for the flight, and then you tell it to fly, and it takes off, flies the mission, and lands autonomously. So there's very little workload throughout the process.
Excellent. Advancing. There we go. So this question was training availability. So do we have training availability, and what does that look like? Michael.
So we have 3 great options for training, and I say they're great because I'm pretty much involved in all 3 of them, so it must be good, right? No. But yeah, so our easiest and first option is absolutely free and just takes about 30 minutes to 45 minutes of your time, and that's scheduling a virtual demo with me. In that virtual demo, we can go over what you want to go over, but some of those options are the data, how we kind of look at that, how we get from data from the drone to data in your CAD software. We'll run through that whole process. We'll show you the drone, anything you want to see on it. And I can also step you through like planning a mission in Q ground control. Whatever you want to know about the product, I'm there, and we'll get you that information. Another great option is a smart project or a smart start. We'll go out, and if you bring out some crew or yourself and you want to learn how to do it, I'll teach you A to Z how I use the drone for the entire duration. I'll process the data right there with you, and we'll get you that data, especially for a smart start, since it's just 1 or 2 flights. We'll get it to you end of day so that you can already start planning on it. And then our last option, of course, is if you go forward with the purchase of a Discovery drone, then we'll provide 3 days of training with that purchase so that you feel 100% confident to take on any job. And then, of course, we also have post-training too. Like if you have questions, my phone number is, distributed to pretty much everybody that we work with. And I'm always happy to take calls, walk you through what you need to know, and help you feel comfortable and confident with using our product.
2 things that I have for that, Michael, is when it comes to the training that's included with purchase, one of my favorite parts is that that's included with the purchase. So that's not an additional cost. That's not something we need to quote. You come out here and spend that time at our headquarters with us and learn how to use this package so you get really confident with it. My other favorite thing, what you mentioned, is with the Smart project, that gives you in 1 day all of the view of this whole workflow. And what you might have missed that Michael shared is that by the end of that day, we'll go back to your office and we'll have the data we collected with you and in front of you in your own CAD software. So this is a way that's undeniable. We're going to go out and collect check shots together using your equipment. We can use your base station most of the time.
Yep.
And then it'll be data from LiDAR collection in your CAD software by the end of the day. No extra subscriptions, no extra costs.
Mhm.
And that's all in one package called Smart Start.
Yeah, that's exactly right. And then just to add on to that 3 days of training, we'll even come out to your job site and do one of those days with you. Like if you have 4 jobs queued up that are, like maybe 100 acres each, and you want to go knock them out, we'll go knock them out with you. And we'll step along the process.
Yes. Okay, ready to move on. So I think this officially is my LiDAR processing section. And what this person wrote in with was, once I've captured raw data from a drone, what are the steps needed for creating a CAD drawing with contours, all 3D features on the ground, with an image in the background? And basically what this person's getting at is, I want deliverables that are similar to a traditional aerial vendor.
Mhm.
They also want to know, are ground control points for the photos required? So there's a few questions in this one. So I'll let you guys take that away.
So I'll hop on when the processing side. When we started this venture, we saw that there was a huge gap here. And so we developed a processor that takes that raw data and turns it into exactly what you're asking for, which is usable outputs. So we have listed here on the right the 3 outputs that we normally get, and we showed you earlier. We have that full resolution point cloud. We also have the filtered ground points, which we remove all vegetation. And then we subsample those ground points to easily import into Civil 3D, Carlson, whatever design software you're utilizing. As far as the photos go, we suggest using the workflows that you've already integrated into your business. So be it Pix4D or Open Drone Map, the photos are ready to import into whatever software you're comfortable with. And as for the last question with the ground control points, we suggest using them for your ortho photo output, because then you can do a tie point. With the LiDAR, we just need that control point with your base station that you normally collect with your rover and base. And Michael's going to now pop up the processor window and walk through a little bit of what taking that raw LiDAR and having it generate points looks like.
Okay, so we're going to demo the LiDAR. I've got a question from the chat right now.
Mhm.
So Darren's asking, if I already use Pix4D with photo workflows, will my current license still function with what your drone is putting out?
So if you're already using Pix4D within your current workflow, then the images that we're outputting, along with the time that we're outputting those images with, will work in order for within your current Pix4D workflow. So the same way you go out with any other camera drone and fly that mission today, you could go out with our drone and apply that same process, but then also have a LiDAR data at the end of the day as well.
Yes.
Thanks. So hopefully that answered that question. I'm going to stop sharing, and Michael, you're going to take over. You're going to demo our LiDAR processing software for us.
Sure am. All right, so yep, looks like it's popped up there on the screen. So it's a really simple, you just find this processor on your desktop, just like any other program, open it up, and then you're gonna add a mission. So this will just be wherever you stored the mission. So I'll use this one from the other day. We'll click open here, and we just click on this exe file that's inside the folder, and click open. So that's gonna bring in that one. And the best part with this new 1.6 that we'll be releasing is we can add multiple files in batch process, which is absolutely awesome. So we're going to put both of them queued up, and then we'll put in our coordinate frames. So once we've added our files, we can add in, that we're in the U.S. state plane 1983. Up here in Tyler, we're in Texas North Central. So we'll scroll down to that and select it right there. We're going to use the GeoID 2018. Our survey, our units are the U.S. survey feet. And our grid distance, we're going to set to 25, but this it's just a text box. We could put in 15, 47. I mean, it's whatever number you want it to be. And then we want to make sure we select this local base station right here. And that'll allow us to tie into our Rhinex file and use that Rhinex data for the PPK corrections to get that really, really accurate data out of our LiDAR. So we're going to upload what's called an observation file. So it's simply the .o file that comes out of your base station. And some different platforms have different names for it and stuff, but getting the .o is usually pretty simple in any brand of base that you're using. So we'll add that in. And then now we will put in our known point. So this is my known point from where I was the other day. And we'll just add those in really quick.
See, Michael's working at lightning speed to get a.
Yeah, trying to get through the not dodging for it, you know? And then this height of receiver is the same thing. You know, if you regularly submit a base file to Opus, you know, this Rhinex observation, then you know exactly what this is, but it's the height that your receiver is from the ground. And ours is 6.56 feet or 2 meters.
Mhm.
And we can add a check shot file tool here, right as well. So if we click browse, we're going to add in our test bed here. Click open. We can set our delimiter to whatever your collector output is from your RTK equipment. And then we can set each one as northing, easting, elevation. And if you have shot numbers or shot labels that you'd like to be kept in, you can keep those in as well. Do you have anything to add before we move forward?
Let's go ahead and look at what the finished result, because at this point you click process and it'll run for about as much time as you had your flight running for.
Yeah.
And then once that's finished, if you just go to one of your
Yeah, bring up like a folder.
sure.
Yeah, so once you've processed this data, it's going to look like this. We'll have all these different files, you know, the raw, the logs, the instructions, imports, but the one you care about most is this finished file.
Mhm.
If you open that up, you're going to get a GNSS report, which is going to give you a charts you can view at to make sure that your GNSS was tight for the duration of the flight. You know, there wasn't any atmospheric conditions that threw off your GPS accuracy. If you process with the accuracy report, you're going to, with these check shots, you're going to get an accuracy report in here as well, which is a text file that shows you each shot that you took RTK and how the drone lined up to that vertically in that same location. To allow you to verify that the drone's data is good. And in reality, at this point, it's just keeping us comfortable and making sure that it hits every time, because it really does. And then you'll get your 1 foot, your 25 foot, and your full process, which is every tree, leaf, and branch.
Thank you, Michael.
So really quick, I know we didn't plan on this, Michael, so pardon me, but would you be able to open up a accuracy report?
Absolutely.
And this is maybe just my preference, but I think what you guys are really going to like about this is when you get this accuracy report and you plug in the check shot file that Michael showed you a few moments ago, that's all coming from equipment, GPS equipment, which your crew knows how to use every single day. It's all coming from equipment that you trust already. And you plug this check shot file in. The beautiful thing about the check shot checker is that you can have a file that's from the entire job. But the check shot checker is only going to deliver a report on anything that's within the scanned area. So you can put in a giant file and it can check this. And then at the end, it shows you that that data is less than 0.2 to a 95% confidence interval. So this LiDAR data, it's classifying, it's doing all the processing for you. And at the end, it delivers a report from your own equipment's measurements of how the drone result did. So you really don't have to trust us. You can really start to use this program and check your own work.
Yeah,
absolutely. And we encourage for those smart starts or smart projects, if you have check shots out there tied into a known point or something, you know, hand them over whenever we process that data and we'll check it against your data. That way we can get, you know, a really good picture of what we got out there.
That's exactly it. Excellent. So you guys think we're ready to keep asking some questions?
Yeah, let me hand this back over to you here.
Got the breadth of the.
There we go.
All right, I'm going to take back over with our slides and we'll get into it. We're going to kick back off here. So we covered what that processing would look like. If it wasn't clear, what you end up with is over here from the LiDAR. So you end up with a full LiDAR cloud. You end up with a DTM or a filtered ground grid that's been rasterized as a 1 foot grid. And you end up with a subsampled ground grid as well in whatever grid size you plugged into the box that Michael showed us. all of this, specifically the subsampled or decimated grid, just gets brought into a CAD software and you make a surface from that, right?
Yeah, because it's all ASCII readable files. So it's all in the same format that you would take on your receiver and your collector. And so the same way that you bring in your collectors points that you shot in yourself, you can bring in these subsampled ground points.
Excellent. Thanks, guys.
Yeah, and we can't stress enough that, we're not putting out, some strange LiDAR surface or something. We're putting out exactly what you get out of your RTK equipment as a text file that's very simple to put in.
Love it. Next one. Let's see here. Is it gonna go? Oh, there's one more here. So
There we go.
when it comes to that LiDAR processing, what other software is needed? And is that a service that SmartDrone provides?
So we kind of jumped the gun a little bit on showing some of our processing software, but what you saw Michael do is all the software that's required. So when you purchase the unit, we provide all of the software included in that package, as well as all the installing software for that executable there. At the end of the day, to process the LiDAR data from raw to your CAD software, that's all you need. In order to get the ortho photos, you would need whatever photogrammetry software that you are comfortable with in order to process those through into the ortho mosaic.
And I think we use a Pix 4D unlimited license that cost us about a few $1,000s a year. Is that right?
Yeah, and we're on the monthly subscription for about $300 a month.
Okay, there you go.
And really quick, before we go forward, I'm recalling something about GCPs in one of the previous questions.
That
Did we
was-
ever address that?
That was this one.
Okay,
So
yeah, there
we
it
talked a
goes.
lot about processing LiDAR data, but I'm glad you mentioned that because there's this photo workflow as well.
So most folks, when they're using GCPs in their photogrammetry, and even Pix4D has all the tools to bring in those GCPs and identify them to your control shots, will have that in their workflow just because they know that they can tie it down and validate the accuracy of the ortho photo. Within this, we highly suggest using GCPs, at least about 5 of them when you go out and collect an ortho photo.
Okay. And in this business, we're always tying things back to known controls. And so to put a few spray paint X's and nails on the ground that you can see is really not difficult.
Yep.
And it's really going to confirm that that data is where you want it.
Exactly.
Thanks, Michael, for that catch. Let's see, that was about any software needed. So we answered that it's the software that gets installed when you purchase this. I don't know that we talked about the services so much, but just to be clear, we will perform LiDAR and aerial mapping services for surveyors and civil engineers who are interested in evaluating the SmartDrone platform.
Yeah.
That's Michael's primary work. That's the type of thing where we go out, collect the data, we process the data using all this software we've shown, and we end up giving you a final deliverable as a customer. And so that's when we'd be processing data, is on a job by job basis. When it comes to the software we're showing with the LiDAR processing comes with the purchase of a SmartDrone Discovery.
Yeah, we built this unit to really empower your business and yourself to process and use LiDAR data every day.
Yep. Yeah. Cool. Thanks, guys. So this was a question. We know that oftentimes some LiDARs have to be calibrated. What is it for ours?
So for us, we do all of our calibration in-house before we ship. And so the LiDAR and our GNSS payload are tightly coupled and calibrated to each other. So, and since it's all wrapped into our drone system, your survey field crew doesn't have to manipulate or change or adjust or assemble. It's all ready to go and ready to deploy. As far as LiDAR calibration, if there is any misalignment within the LiDAR, we use a solid state spinning LiDAR, which doesn't have as much issues with the misalignment because it's a chipped down solution.
Yep. So we have a very robust and
Yes.
reliable LiDAR sensor that isn't going to come out of calibration.
Yes.
Yeah.
What would you think?
So what's another benefit of a digital like LiDAR as opposed to an analog LiDAR, maybe as far as upgrades and advancement in the future? Good question.
So with our digital LiDAR, what's really cool about it is it's more akin to a digital camera than your traditional LiDARs that you've seen. And so what we have been rolling out has been software upgrades to the LiDAR firmware itself that over time adds more feature, add more accuracy, and that's allowed us to really kind of produce better and better over time.
Yeah. Thanks, guys.
And Al, I don't know if you're seeing these messages, but it looks like there's 1 or 2 people that are having some trouble getting in. That Victoria's letting us know about in Slack. Is that something we want to try to mess with right now, or?
Let's keep moving.
All right.
And we will be publishing this, guys, just a reminder.
Yeah.
This is being recorded right now, and we will publish this to YouTube so that everybody who wasn't able to make it in will get to benefit from it and have the same experience.
Sounds like a great plan.
So the section that we're continuing on is in accuracy. And so can LiDAR be performed with snow cover if we knew the depth of the snow and if it was uniform?
So the LiDAR frequency we use is reflective with snow. And so if you knew the depth, you could Z-bump the entire collection if the snow is uniform. And also if you had collected prior and you can kind of look at that offset, that might be another way to derive that.
Okay. This question talks about accuracy, but what they're asking is what's better, photogrammetry or generating clouds from images, or LiDAR?
So I've seen that they each have their place. Photogrammetry is really good at picking out horizontal components and saying, oh, that edge of curb, that parking stripe. LiDAR is really good at the vertical piece of it, where if you're trying to see through trees and vegetations and get a full picture of the elevation, LiDAR can't be beat.
This question is also about accuracy. Can drones hit topography standards?
Yes, absolutely. We hit a 210 standards, which we keep every drone and test every drone to. The NMAS standards for a 1-foot contour, it says 3/10, but we find that 2/10 is what our customers want and expect out of a topography solution.
Okay. And one other part of the standards that drones knock out of the park is the density of the LiDAR data. A lot of the standards were made for airplane stuff, but what type of points per square foot or points per square meter in terms of density do we hit?
So the QL standards specify that we need 8 pulses per square meter. Typically per square foot, we're getting about 32. So we get an order of magnitude of 10 to 20, what the national standards call for.
Absolutely. All right, moving on. Can drones identify trees?
This is a really interesting topic that some people have been asking about often. And what we've seen is that with photogrammetry and LiDAR, they can, but our software that we've developed is really focused on generating topography and bare earth models. So we give you all of the data product in order for you to go in and identify, but you also will get the topography product right out of the gate.
Okay. Cost. It's one of the biggest questions we get. So these two are pretty similar. What are the entry costs for LiDAR drones? And what is the cost for a basic set? This is someone who wants to handle 10 to 20 acre topo tracks on a regular basis. He calls them small.
Yeah. So I'll go ahead and answer this second question first, and then maybe Al can help me a little bit with the first question as far as what the entry cost for, like any LiDAR would be. But as far as the cost for us for basic set that can do aerial topo is $64,999, as you see on the screen there. And that includes our drone. That includes 3 sets of batteries, or 6 batteries total. That allows you to cover about 150 acres of coverage. And everything else you need to fly the drone, the controller, chargers, if it is needed for the drone to work, you have it. Did I mention the processor already? That includes a perpetual license to our, advanced aerial mapping processor for LiDAR. Am I missing anything, Taylor?
Blades.
Blades, yeah. Comes with the blades.
Yeah.
Yeah. But no, that's about it. I think you covered all of the whole package. Ultimately, we wanted to provide something that when you got it in your hands, you feel like you were ready to have your survey crew begin to handle these LiDAR jobs that day. We didn't want to try to jump the gap between the learning and all of the nickel and diming that we've seen in the industry by just providing a flat solution.
Yeah.
In this one price, this is the price. We're launching the Discovery 2.0 right now with a camera. We haven't changed the price. And 10 to 20 acre treks can be very profitable, especially when you consider the terrain. I would say one of the best things to do, we've actually got a spreadsheet where we can help model profitability. You can tell us what different crew costs would be. Sign up for a virtual demo. We're going to share more about that at the end. Sign up for that, get with Michael and have him walk you through that, what that would look like. Or sign up for a Smart Start. It's $2,500. We go out and scan up to 50 acres. So if you had a 25 acre tract you want us to scan, we'll scan it. You'll have the data that day. It's a really simple, undeniable way to say whether this would fit or not in my workflows.
Yeah. And one thing that we should clarify whenever we say you'll have the data that day, we're specifically referencing our LiDAR data. If we're taking an orthomosaic at the same time, the processing times through Pix4D is a little bit longer than what our processing time is for our LiDAR data.
Awesome. So that's all the information about costs.
And then did we want to address like what the entry cost for LiDAR drone is? You know, what do we know about that?
Well, I don't have everybody's numbers in front of me, but I will say that we've really studied what's out there in the market. We have made sure that what we're offering is very price competitive.
Yes.
I would, maybe a piece of advice, we're certainly biased, but do check out whoever you want to go forward with and really dive into what those processing costs would look like. I think that's got to be one of the biggest values we have, is that there is not a subscription for our LiDAR processing suite.
Yeah.
That classification and processing can cost tens of thousands a year in different subscriptions. And we have seen where unlimited packages aren't actually unlimited, different things like that. So what I'd say, being in the industry, I'd say have a demo. Bring them out to your job site as you evaluate these different groups, as you narrow them down. Virtual demos, see some real demos. Make sure that you could replicate whatever they're showing you with that drone, because sometimes it's a little bit harder to use than you might guess. And sometimes there's a few more extra costs that get piled on that you didn't even realize. So we're really proud of our kind of just one fixed price Model T type of mentality. It just makes it very easy to understand.
I think that sums it up really well, Al. Thank you.
Good. All right, I'll take this one. So this question is, what types of insurance is available for drone mishaps? And then what are the costs? So your costs will vary based on your insurance history, your business, everything like that, and the broker you choose to use. But in general, there's about two types. There's a general liability policy. So you can buy this by the job with an app or online. You can also, though, go to your regular business insurance group and get one of these policies for the year. They're typically less than $200 a month, and for 1 million, 2 million coverage, general liability policies. Alternative, or in addition to, some people like to do is what's called hull coverage. I've also heard it be called inland marine. In my analogy, it's like full coverage car insurance.
Yeah.
So you're going to have a deductible. They probably are going to be a little bit more strict about who can get this coverage, especially for such a high value product. And what we've seen is that they'll have people take pictures of their safety processes or of their setup of the drone. They'll have them take those pictures each time. So your insurance carrier may have some workflow things that you need to learn about, but this is going to cost about $6,000 to $8,000. And if your drone had any issue, and as long as you followed FAA guidelines, legal federal flight guidelines, and the insurance broker's needs, you would be able to get a replacement drone. So the whole coverage is definitely something to think about, especially with these things going on with field crews. You may not, just anything could happen, I guess is the best way to say it.
Yep.
Oh, sorry guys, I went the wrong way.
I forgive you, Al.
Yeah. All right. So Don't worry, we're getting to the end. And thanks everyone for hanging in with us. And sorry again to anybody who's watching this later on that wasn't able to make it in the room. Sorry if we had some technical difficulties on our end, and we'll make sure to make it easier to get in the next one. But this question is, how do I know I need a LiDAR drone? So I'll start it off as I like this bullet point. Do you operate in heavy canopies? That's a pretty important consideration. We showed some pictures earlier of the pine plantation that we live near. We wouldn't have a lot of other choice. So if we were a surveyor, that would kind of be part of our decision being made for us. But Taylor and Michael, what do you think?
I think one thing that has really stuck out to me when working with some of our early adopters, so to say, is that as soon as they start giving their data products to their clients start to expect it. So what I would say is to really evaluate what you think the next generation of data products will be, and think if you want to fit yourself into that type of business model.
That's pretty interesting though, Taylor, because we did get called up to do services on a job a while back. It was our second or third job for the customer, and they called us out to an open field.
Yeah.
And we could not figure out what we were doing there with a LiDAR drone. It was a 30-acre open field. And what came out was we had done a 260-acre project for that same client, and their civil engineer said, I want that much data.
Yeah, because I think people are starting to really hone in on the fact that rework is the most expensive part when you're doing any survey job. And so preventing that rework by kind of taking that whole collection, and if, you know, how do I know if I need a LiDAR drone? Well, if you're tired of rework, then I think that's a great way.
That's a great way.
That's a great qualifier.
I'd say another qualifier is, you know, how much do you want your crews to be able to get done? You know, if you're a small surveying department with maybe 3 crews, you know, 3 crews of 2, and you were able to outfit each one of them with a SmartDrone, they'd have the ability to run massive topo jobs and run a boundary, you know, with 2 people, and be able to topo that area pretty quickly as well. So you can get that nice hybrid workflow where you have boots on the ground still, they're running the drone, they're running your boundary, but you're also able to augment them and help them become more productive with a tool such as the SmartDrone.
That's a great point, Michael. Anything else that you guys can think of? I have one more now that I'm thinking about it. We have customers talk to us all the time, land surveyors, and they get big jobs that come across their desk on a regular basis, but they just don't have the crew for it. And so they're not even bidding some of these 200+ acre subdivisions and large jobs that could really mean something to their business. Is because they don't want to burn out their crews, or because they can't hire enough crews fast enough for the amount of work. Whatever the reason is, they're all facing it. Every single surveyor you talk to, I haven't met a slow one, and they're all facing just fun. We have great crews if we could just duplicate them. Like whoever I've got that's sticking around, if I could just multiply them, right? Well, in a way, especially these big topo jobs that are so labor intensive, if you could bring in sort of a augment to your current team, don't replace the team, but if you can now bring in this drone and your team can crack off 300 acres of topo in a day, well, you know, your favorite crews are now even more your favorite almost.
Exactly.
So, okay.
And a point on that, Al, is whenever you're seeing these jobs come up, give us a call. You know, even if you don't have the job yet, we're happy to provide you with a quote on the job, you know, based on like a KML on Google Earth. And we can get you the exact number it's going to cost us to go out and do it, so that you can quote, you know, and I guarantee you our number to do that job is going to be considerably lower than a number of getting a crew out there to do the same thing on a large topo. So give us a shot.
And with that as well, if you have something underneath 50 acres, then sign up for our Smart Start. We will come out and we'll show your crew. We'll give a little bit of training to your crew on what this product looks like and what their future might look like as a survey crew.
Yep, absolutely. Thanks, guys. So from the audience and in the chat, are there any additional questions while we're saying this part? And then this is just to reiterate that we will be recording this. This has been recorded, and this will be going up on YouTube so that everyone can watch it over and over and over.
I see one about 107s, and I think that's a question that we get all the time, is what does regulation look like in order for my survey crews to begin using this ASAP? And so when we have our virtual demos, we'll typically give some information about how to speed up the Part 107 process? And Al's really done a lot of studying into this.
Sure. The other thing is we've got a study guide that we put together, and that's actually a part of the Smart Start program. So like Taylor was saying, we take this study guide. We have 10 or 12 people on our team, from the accounting staff, front desk. Everybody in this building is Part 107 certified. That was one of our edicts from our CEO. So he said everybody will become certified even if we have a janitor, right? So we couldn't pay $300 for every single time we went through and hired someone, and they had to go through these programs. And the other thing is that the training guides we found online were really hard to follow and kind of demoralizing. Like, it really made me feel like I couldn't learn how to do
It's a
this.
semester at college, not a
Yeah.
prep for a test.
Yeah. So if you guys are in one of those, or you feel like you're going through one of those and it's daunting, please reach out. Whether you go forward with the services with us or not, we would be, like Taylor said, glad to share on a virtual demo what this study guide is. It's a series of links. It's something we've curated and put together that make it a whole process you can just follow for free. It uses a YouTube video. It has different free study guides. You follow this process, you do what we say in this guide, you're going to get certified. We have a 100% pass rate. It takes about 2 weeks to study. It's free to study, and then you spend about $100 getting your certification. So that is one of the biggest concerns, is how do I get my crew certified?
Yeah.
I believe you could have someone who's still working get certified in about 2 to 3 weeks.
Yeah, I think that's a great point, Al. And something you kind of touched on is that we're not charging for this study guide. It's something, schedule a virtual demo with me. We'll run through some of the different stuff. We'll run through the study guide some. I'll give it to you guys. One of our, values as a company is, we want to be a value add to the industry. And obviously we would love it if you bought a drone through us and bought services through us. But what our key thing is, we want to be a value add to everyone we come in contact with. And so that's why we have some of these free distributables to help people, evaluate drones and Lidar and photogrammetry and if a Part 107, all that different stuff that we can give out.
Yes. And sort of wrapping up here a little bit to that point, is that we see less than 5% of the market is using drones and Lidar drones on a regular basis. So this is an underpenetrated market, guys. And what that means to us as a business, it's our job to educate. It's our job to become a trusted resource and to be able to help you. And so we really focus on that, just like Michael was saying. Reach out if you have any questions in the drone space, even if they're not exactly surveying and mapping, and maybe there's a chance we could help. But Michael, our final question, how can I learn more? What are some ways I could work with SmartDrone?
So that's a great question. Our website that Al put together for us is really nice, really streamlined, really easy to run through. And there's links for virtual demos, the Smart Starts, the Smart Project, learning more about the Discovery drone. All of that is available at www.smartdrone.us. You can also, you see the link there on the screen. If you put /demo, it'll take you straight to the link that allows you to set up a meeting with me. And then you can also see there's these QR codes on the screen that allows you to start through that page for a virtual demo or a Smart Start. And if you're sitting there watching, you can actually, I thought this was the coolest thing earlier, but you can actually use your phone, and just take a picture of the screen, call me a boomer or whatever, but I think that's so cool. And then my email address is also available right there at mash@smartdrone.us.
So you guys heard the man, QR codes work on screens.
Yes, they work on screens, guaranteed. That's a smart drone guarantee. Yeah. If you do it right.
Yeah. The last thing I'd add, if we're going around to most surveying conferences. So if you're in, you guys are going to be in Virginia or
Tennessee next week.
next
I think
week.
we're going to Virginia the week after.
Early March, somewhere around March 2nd, is the Tennessee Association of Professional Surveyors.
Yep.
Guys, come see us there. And then we have a Geo Congress in North Carolina, I believe,
North Carolina,
mid-March, around the 20th. So if you're in that area, please come say hi. We'll have a booth at both of those events.
Yep.
So as we're wrapping up, I want to say thank you to everybody who made the time to come and attend this AMA. It's really made it special for us, everybody registering. We feel really grateful for the opportunity to get to share some of this information with you guys. We feel really grateful for your questions. It's really cool to see some very specific questions that show that people are really looking at LiDAR drones in general. and looking at what they can do for their business. So do you guys have any thoughts before we wrap up?
Just like you said, thank you so much for your interest and thank you for your questions. A lot of these questions were very good, specific questions, like I was saying, that were that we enjoyed going through and finding answers to and putting together little slide decks to be able to give you the answers and be a value add to the industry. Got anything, Taylor?
Yeah, 2021 was a great year to watch our product begin to be used by customers and adopted kind of in our local area with all of our field application specialists. And it's really exciting to see 2022 be the year that seems like people are really going to start picking these up and putting them to work.
Yeah.
Awesome. All right, guys, we're going to do this again. We're thinking maybe quarterly. So be sure and get with us. Let us know if you'd like to attend the next one. We will be reaching out after this to share the video link and make sure any follow-on questions, if we didn't get to them, are answered.
Yeah.
So I think that wraps us up. You guys think that's it?
Like so?
Sounds good.
Cool.
All
Thank
right.
you.
Thank you
Thank
very
you,
much.
everybody,
Thank you,
for
guys.
joining us.